Great. All right. Hello, everyone. My name is David Reveman. I'm a software engineer at Rivos. Rivos is a hardware startup based in Santa Clara. And today I'm going to talk about the work that we've been doing with the Velox team to enable acceleration on the hardware that we're building using Wave. So here's the short agenda. First, I'm going to talk about something called Breeze and tell you a little bit about what that is and how it's being used by Velox Wave. And then give you an update on the current status of how the integration into Wave, and then a little bit about what's coming next. So what is Breeze? So Breeze is really it's a header-only library providing SIMT acceleration for data analytics algorithms. So originally, this was developed internally at Rivos to help us with our hardware design and to understand how to, build the right hardware for accelerating data analytics. And by working together with the Velox team, we decided to open source this code. So it's the initial part of the code is now living in the Velox repo, and you can find it in the experimental folder. It provides a portable implementation of a bunch of building blocks for data analytics. So it's portable across both APIs as well as architectures. So it means it's not limited to CUDA. It will also work with HIP, SYCL, and OpenCL. And it's not making a lot of assumptions about the architecture that it's running on. So for example, it might not make any specific assumptions about like register file size or shared memory. It tries to be pretty flexible there. So that it will scale well to multiple architectures. There is a mechanism in there to support vendor and architecture-specific specializations for optimal performance when that is necessary. So, for example, sometimes you might want to reach for some on Nvidia hardware for some PTX code that is not available using the normal CUDA API, then there is a mechanism to do that, or some other kind of compiler built in that you can't access using the standard API. So there is a mechanism to do that, and there's a proper abstraction, so the code keeps being portable. It's kind of designed to easily integrate into existing projects. We want it to be as simple as possible to use this in existing code. So you kind of just want to be able to copy a header, put it in your project, include it, and use it, and that it should be as simple as that. So in some ways, you can kind of think of it as, if you're familiar with a cub, you can think of it as a cub, but with a focus on data analytics. And whatever the needs are for Velox Wave, and also being portable across APIs and architectures. So a little bit more about the design. So there's different API levels. Sort of at the lowest level, there's something called like a platform API, and that's where you can find some pretty basic things like things that might be different depending on the API you're using, such as how do you get your thread ID and special warp intrinsics and so on. You'll find that, and as a user of this library, you can decide just to use that to use that abstraction. On top of that abstraction, there's a large set of what we call like kind of block-wide functions that are built on top of the platform API. So you can use that. If you're familiar with Cub, this is very similar, and similar to the sort of the block-wide functions in Cub. And then on top of that, we also have an API level that we kind of refer to as algorithms. So that's basically a lot of these block-wide functions being combined into more complicated algorithms, like, for example, radix sort or something like that. So those are sort of the levels, and you can kind of pick and choose what you want to use. And I'll in following slides I'll go through kind of what Wave is currently using, and that might change over time too. We have a really exhaustive set of correctness and performance tests for each of these levels. That's helped us design our hardware, of course, and it also makes it easier to get new architectures to be correct and perform well when using these functions. For the performance test, we actually have one more level beyond the algorithm, which we kind of refer to as queries, and that's basically taking the algorithm API and combining that into sort of higher level SYCL queries. And that can be kind of used if you want to find out what the speed of light is for certain specific SYCL queries. You have some hard coded queries there, so that's also in there. Another design decision is that we decided to keep all sort of policy and configuration external to Breeze. So we like all parameters that allow you to configure these functions, such as maybe the number of threads per thread block or the number of items per thread and those type of things. Those are all external. We don't make any assumptions internally in the library about what are ideal values. We basically allow you to provide them, and we have the performance test that allows you to do sweeps to determine what might be the ideal configuration for your specific piece of hardware. Okay, so what's the current status of integration into Wave? So we have been working with the Velox team to integrate with Wave, and right now we're using for some things we're using just a platform API. So these are basic things where you currently, if you want to do it in CUDA, you might have to reach for PTX or some other library that is less portable. So, for example, libc++ atomics with memory ordering and memory prefetching. So some of those things we get through the Breeze platform API, which allows us to specialize it for Rivos hardware as needed. And then we're also using some of these block-wide functions today. So those are mostly kind of basic scans, reductions, and sorting. So it's pretty limited, but the exciting part is that this is enough for Velox Wave to now work with multiple hardware vendors and multiple architectures, because it's now running on Rivos hardware in addition to Nvidia hardware. Okay, so what is next? One thing we can do is we can, potentially add or migrate some of the existing Wave CUDA code into Breeze. Whether that makes sense or not might depend on different factors, but it would make some of that code more portable, and we would benefit from the correctness and performance testing that Breeze provides. So if you have some code that maybe needs tuning to perform really well across different architectures, that might be a good candidate for being moved into Breeze rather than living in the common Wave code. Like I mentioned, this is code that has been open sourced from Rivos. There's a lot more code internally that we haven't open sourced yet, so we are planning to open source more of that, and it's probably going to be based on what is most useful for for what we're doing in Wave and Velox. So we'll be working closely with the community to determine what is the most useful thing for us to open source. And obviously, if there's interest, we be very excited to potentially support more hardware vendors and more architectures. And given that Breeze already runs all the correctness tests and performance tests already run on with other vendors' hardware, we kind of create a path forward for doing that. It's relatively straightforward. Okay, so to summarize, Breeze is open source and it's part of Velox. It's how we enable Velox Wave to provide acceleration of Velox on multiple hardware architectures today. And it provides a robust set of correctness and performance tests that we can use for key software components in Velox that potentially use tuning. And it also provides a path for supporting more architectures and more vendors in the future, if desirable. And yeah, and last, I want to thank the Velox community and the Velox team for working with us, especially Ori and Jimmy, who's been doing a lot of hard work reviewing our code. And yeah, and by the way, Rivos is hiring. Thank you.
Could you talk a little bit about the extent of your the performance data that you expose? Is it just like wall clock time, or do you have a workbench that you can do experiments and garner other information about what's going on underneath that are important for understanding performance?
I mean, the basic stuff is just wall clock time or whatever profiling that the specific API provides that you're running the test on. You probably have to reach for specific tools that the vendor provides if you want to do more deep dives into exactly what's going on. So we'll have, we have our tools, and obviously if you're testing this on NVIDIA hardware, you use their Nsight tools to get more details.
Okay, thank you.